Hey there, Year 11s. We're going to have a look at this CAT for 2012. So let's just crack on. So look at the first question here. And this question is asking us to solve, and there's a number of ways to do this. I think the easiest way is to start by dividing both sides by 3. The reason why I think that's easy is because that lets us eliminate that 3 out of the front and leaves us with 2x plus 9. Over here we've got 15 divided by 3, which is 5. So now our next step of working is to subtract 9 from both sides. So our 9's eliminate from that side and leaves us with 2x equals, and then 9 minus 5 is negative 4. Okay, after that we can divide both sides by 2, so 2's cancel out, and we're left with x equals negative 4 divided by 2, which is negative 2, and that's our final answer. Okay, question B1 is asking us to factorize, and so that means put it into brackets. And here we're going to put it into 2 brackets because it's got an x squared, which indicates that it's a quadratic, and it has 3 terms in total. So I've got x at the start of each set of brackets, and we're looking for 2 numbers that multiply to negative 28 but add to negative 3. So let's list some multiples of negative 28 here. So we've got negative 28 and 1, that's the obvious 1, and 28 and negative 1. We've got 14 and negative 2, and negative 14 and 2. None of these so far add to negative 3, so we'll keep on going. So I've got 7 and negative 4, and 4 and negative 7. Now these ones are different by 3, so this one here, if we added them together, we'd get positive 3. This one would get negative 3. So that's our pair that we're going to put in here. So we've got plus 4 and minus 7. Now our examiners love to do this for our next question, where they've given you a big hint by telling you to do a step first before you get here. So if you notice, these two expressions are exactly equal, and the second one is just asking us to solve when it's equal to 0. And so let's have a look at what happens when we do that. So we'll go straight to the factorized form from our last question, which was x plus 4 and x minus 7, and we'll just make it equal to 0. And so from quadratics we know that these two brackets have to be equal to 0, so we say either x plus 4 equals 0 or x minus 7 equals 0. And so for this one here, for x to add to 4 to get 0, x would have to be negative 4. And for this one here, for x to subtract 7 to be 0, x would have to be 7. And those are our 2 possible answers. Okay, as we move on to question 3, we continue to see the hint. The top here is still the same as the what we had up here, and so we're going to factorize the top straight away. So let's write that out, and we'll leave the bottom the same, x plus 4, and we'll factorize the top. So x plus 4, x plus 7, minus 7 again, and we'll extend that out the top. Okay, now we start to notice things, and we can see that we've got x plus 4 on the top and the bottom, and so they cancel out, and so we can say that it's equal to x minus 7, and that's all. Okay, so if we're looking at our next question, continue to notice that we've had a pattern going the same way, and so all the big hint that they're giving here is, instead of writing all of this, just write it as x plus minus 7, because that's what it simplifies to. So let's do that. So we'll write x minus 7 equals 5, and if we add 7 to both sides here, that gives us x equals 12, and that's one of the solutions, or they've told us that that is the only real solution. But there's a little bit more to do here. So we really want to see if we can solve this in a slightly different way. So let's just see what happens here if we were to times both sides by x plus 4. So let's do that, times both sides by x plus 4. And what that does is cancel the x plus 4 off the bottom and leaves us with x squared minus 3x minus 28 equals, and we'll expand our brackets here, 5x plus 4. So now we'll rearrange this. We'll subtract 5x from both sides, and we'll subtract 4 from both sides. And the purpose of this is so that we can make one side equal to 0, because we've got a quadratic. Okay, so that gives us x squared minus 8x minus 32 equals 0. So factorizing this equation, we're going to have x in the start of our brackets, two numbers that times to negative 32 and add to negative 8. So let's see here, we could have 32 and 1, we could have 16 and 2, we could have 8 and 4. What else could we have there? So we're getting to a bit of an impasse here because it doesn't seem like we can easily factorize this. So in fact, what we might just do here is check that our working so far is correct. And so if we just have a look back here, I said 5 times 4 equals 4. Well, that's not right, that's 20. So I need to subtract 20 from both sides, not 4. 20, 20. And so that there is going to be minus 48. And so that gives us, that means that we've got negative 12 and positive 4. Okay, and so our two solutions are x equals 12 and x equals negative 4. Okay, so there's our two solutions. Now, they've asked us to show that 12 is the only real one. And if we go back to our original equation over here, if we put 12 into that equation, we'll get 5. Let's see what happens if we put 4 into it. So I'll just write it out here because I've got a bit more space. So x squared minus 3x minus 28 over x plus 4. Let's put negative 4 into this equation and see what we get. So we've got negative 4 squared minus 3 times negative 4 minus 28 all over negative 4 plus 4. So that gives us 16 plus 12 minus 28 over 0, and that's a bit odd. So 16 plus 12 is 28, 28 minus 28 is 0, 0 over 0. Now 0 over 0, a lot of students think, oh yeah, that means 0. Actually, it's undefined. If you go into your calculator and go 0 divided by 0, it will give you something along the lines of MA error, something like that. And so what we just say here is that's undefined, and so x equals 12 is the only real solution. Alright, so a relatively involved question there, so as you can probably guess, if you can take it that far, you're looking at excellence level for that particular question. And we'll end this video there, and we'll go on to question part 5 in our next video. Thank you.